Good morning. Welcome to the Monoxivent webinar series. My name is Ian Frank. I'm a Vice President at Monoxivent. Today's presentation will focus on Monoxivent Specialty FRP Duct. Our presenter is Terry Cahill. Terry is a Senior Product Manager at Monoxivent, has been with the company since 2008. Terry has 30 plus years of experience in the industry, and also with us today are two of our engineers, Sam Stelzner and Brian Phipps. A bit of housekeeping for today's webinar. In the lower left corner of your screen, we are encouraging participants to text questions to us. We will read back the questions and answer throughout the presentation in an effort to encourage dialogue throughout. Monoxivent Specialty FRP Duct includes hybrid lab duct, the L3 connection, and underduct VE. So without further ado, we'll go ahead and turn over the presentation to Terry.
Good morning. Today we're going to talk about our specialty ducts, but first of all, I'd like to go to our standard product offering. Underduct is for heating and ventilating underground. It's a Class 1 duct material. It's ICC listed. Our listing is PMG 1171. We started that in that brand name in 2008, and it's been very successful. Corrosion Composites is the old line, well established by ASTM standards and the original standard NPS PS 1569, and this is all about wastewater plants, industrial, corrosion-resistant fiberglass. A very well-established market driven by these standards. ASTM C582 and D3982 are the ones that govern duct for the most part. Also, SMACNA has a thermoset manual that covers the corrosion side. Especially fiberglass duct often requires corrosion resistance and a Class 1 duct rating for flame and smoke spread. Monoxivent's design and manufacturing expertise goes back 40 plus years in both the corrosion market and the HVAC fiberglass duct market. Our hybrid or lab duct, which we're going to emphasize today, bridges the gap between these two product lines, but it's fast becoming a standard for us. Another specialty duct that we've developed is our VE duct to meet the unique requirements for underground vehicle exhaust. The laboratory fume hood duct, or hybrid CF, it's corrosion fire, was developed for occupied space, but if you consider the application, a laboratory fume hood may be generating strong acid fumes. The acid fumes, or caustic fumes, have a tendency to condensate in ductwork and become even more corrosive. So it's very important to have a corrosion-resistant interior. And if it's a building where people are working or school students are there, you need to have the Class 1 duct exterior in case there's ever a fire. So that's the reason for developing the laboratory duct or hybrid CF. Again, applications are hospitals, aquariums, dog kennels, exposed vehicle exhaust, swimming pools, laboratories. The hybrid lab duct principally, the interior follows ASTM C582, and that defines what the inner corrosion barrier is. The corrosion-resistant resin and the C-veil or another veil, depending on the chemical application. And the exterior would have the flame and smoke rating required for the exterior and that structural layer. Typical applications, exhausting corrosive fumes from an occupied space, requiring a Class 1 duct, having an ASTM E84 flame spread of 25 and a smoke development of less than 50. Typical examples are laboratory fume exhaust for schools, hospitals, and industry. Also, corrosive exhaust from occupied industrial areas, such as plating lines, metal pickling, chemical etching, and many other types of workstations. Here's an example, Northwestern University, Evanston, Illinois. There's a 5-story building of new laboratory, and the fiberglass duct serves fume hoods on all 5 floors. And we're looking at some photos of the mezzanine area where it all comes together. The lower picture, you get a good look at an L3 joint, which is our low VOC joint, which we'll explain in a minute. Next, we're looking at the Fridley water plant in Minneapolis, ammonia addition facility. Water plants add chlorine to the water as it leaves the plant and goes out to your homes and business. And what they call residual chlorine is what you end up with in your tap at home. And it's always been very difficult to control. And it's very important because that's what keeps our water clean and safe. It was discovered maybe 10 years ago that the addition of small amounts of ammonia can control that residual chlorine. So the Fridley water plant, being the major surface water plant for the city of Minneapolis, put in this ammonia addition facility. And there's lots of controls in there. They produce ammonia, they add it, and there's people in and out of there all the time watching the controls. So it's an occupied space, and it's an excellent application for hybrid duct. And below we see Hampshire, Illinois water plant. And this is a chlorine room where they add the chlorine. You can see a chlorine scrubber to the left. And again, being a small municipality, the operator will have an office right in that room. So again, they need to have something that's going to meet the claim of smoke rating.
Barry, we have a question that has come in where the visitor is asking, can we make FRP registers and grills?
Typically, we do not. The registers and grills that are used in corrosion situations, I've seen stainless steel, aluminum, and PVC. But we do make some passive types of grills and registers using grate, but typically no. We provide a 1-inch flange that the grill or register can be screwed to in the field. This is our low VOC coupling, the L3 joint. And this is developed for several reasons, primarily lead. And the lead requirements call for less than 80 grams per milliliter of VOC in any adhesive or materials brought into the job site. And we have an adhesive that works with the center sleeve that you see in the photo. And that eliminates the VOC. The other part of this is the low dust, and there's a material called peel ply that's applied to the sleeve and to the interior of where the joint is. And every joint on the job goes out this way. And it's a matter of putting the adhesive on and after you pull off this protective coating. You don't have to do any grinding. And we've tested it to 15 psi. It seems to work very well. So it's a valid joint. Next, we're going to go into underduct VE. And underduct VE is probably one of our fastest specialty duct areas, fastest growing. Because vehicle exhaust is very corrosive, you can get carbonic acid, you can get nitric acid, sulfuric acid, all can condensate out in that ductwork. from vehicle exhaust. And the fact that it's buried underground is important. And we also have a temperature requirement for it. And the temperature requirement, we've done some testing, which we'll show you in a bit here. Make sure that we can do it. The VE duct is a better idea. Monoxivent started with vehicle exhaust equipment back in the 50s. Crawford Company, our parent company, acquired Monoxivent in the year 2000 and expanded the line to include all of the source capture applications that we have today. Vehicle exhaust, welding fume, dust collection, etc. Monoxivent's in-floor vehicle exhaust system has been around a very long time in car dealerships and maintenance shops. And in the past, galvanized or PVC duct was used because that's what was available. PVC can't take the heat, and galvanized corrodes and leaks. VE duct is the only duct that meets the specific needs for underground vehicle exhaust system. It's corrosion resistant to the exhaust gas and condensate. It is corrosion resistant to the ground conditions, which can be acidic or caustic, especially if there's moisture around. And it's heat tested to 325-degree excursions to 400 plus. It's approved for direct burial, no concrete encasement required. VE duct will not leak when installed properly. It's been tested. VE duct is the only ICC-listed vehicle exhaust duct certified to meet building codes. The photos we're looking at, Minnesota State University at Winona. This is an auto tech room that's going in at the university. And there you see the long sections being joined that will be then put in the floor. Here we're looking at an installation at Marquette Motors in Chippewa Falls, Wisconsin. And what you see are the workers putting Monoxivent stainless steel pieces with the saddle on the duct. They're using duct seal and stainless straps. And they position them all. If you look at the center photo in the middle, you'll see they've now compacted all the sand. And they're ready to pour. The next photo on the right shows the finished product. The hoses in this system, the hose is stored in the duct itself.
Terry, we had a question on this slide here. Why not use PVC plastic? They use it underground for plumbing all the time.
Because the temperature requirements for vehicle exhaust are too high. PVC can melt at 140 degrees. CPVC is rated at 180. And we've tested ours, as you'll see later, up till really 700. But we've estimated that a typical vehicle exhaust system can see 325 degrees possibly. So that's the reason for not using PVC. Here are some pages from our Monoxivent source capture catalog showing the system and how to install it and so on. And it's the in-floor system with the trapdoor. All this is online and available. This system is one that instead of storing the hose in it, you just open the door and you hook your hose up to the nozzle inside. So there's two ways to do the in-floor system. And this is a typical application where you see the ductwork is pitched to one spot, and this is where the ductwork would exit. And we strongly recommend this type of sump built into the bottom of our riser that you see on the left. And this allows you to, if there were a flood, you could throw a pump in there and pump it out. Or, you know, in the case of a wash down, sometimes they wash the salt down from the floors and it all end up in there and you can pump it out. And the Monoxivent refuse clean out unit, which is again a catalog item, can sit right on top of that and allow you to get in there. Next, I want to show you the ICC-ES PMG listing that will be effective November of this year, 2014. If you look in the upper left, this is all the testing that we went through 2 years ago to get the ICC listing and the PMG listing to show that Underduct meets the building codes, the International Mechanical Code, the Uniform Mechanical Code, and so on. And what we've done is this year, through this application, we've also had them include the vehicle exhaust. And you see the highlighted area, underground single-wall duct for vehicle exhaust applications. So this means that it meets the building codes. On the second page of that document, underground vehicle exhaust duct is addressed again, and it states the requirements that it has met. Okay, the ICC testing didn't include anything for high temperature for vehicle exhaust. So what we did was we set up a procedure, and you see in the upper left photo, Sam and Brian, and we have two sheet metal duct sections that are 5 foot long, and we put a 1 foot long piece of the PE duct in the middle. And then we have a temperature probe to check the temperature, and the readout device is shown on the right. So we had a very good setup, and we maintained the temperature for 10 minutes. Now the ICC requirements, they tested it for flame and smoke. They leak tested it to 6 foot below the water table, and they strength tested it using ASTM 2412. And then, as I mentioned, the way we addressed the temperature was to set up this procedure and run these 4 samples at 200 degrees F, one at 300 and one at 400, and then we took the last one up as high as we could get it, and we had about an average of 750 for 10 minutes. Each sample was then strength tested in accordance with 2412.
We got one more question for you, Terry.
Sure.
The question is, will most code officials recognize these standards and disallow the use of PVC, for example?
It's up to the local code people. It's their duty, as I understand it, to check things out. But if they were to call ICC, they would see that it is listed, and they do look for the PMG listings. So a local code official might say, well, we've accepted PVC, but it doesn't really meet code. So that's an arbitrary area. Once they know, then they're pretty cautious about it, and it's up to us to inform them that we are indeed meeting the building codes. After we ran the temperature testing, we visually inspected the samples for color change, blistering, cracking. The only effect was a slight color change in the 400 degree and the 750 samples. We then tested the physical properties, again running it through the 2412 procedures. The 2412 procedures, the name of the test is Standard Test Method for Determining the External Loading Characteristics of Plastic Pipe by Parallel Plate Loading. If you look at the right, this is our apparatus, and there we see the apparatus where we're pressing the pipe down. And the whole thing is, the test determines the PSI needed to deflect the diameter 5%. Standard requires a minimum of 8 PSI. When we tested the 2200 degree F sample, it deflected 5%. at 72.77 psi. The 300 went to 88.88. The 400 to 94.44. And then 750 went back to 75 psi. Now, one of the things that we kind of discovered here is that essentially what we were doing was heat curing the resin and making it even stronger. That is a common practice with some resins, to heat them up to make them even stronger, give them stronger properties. But what we really wanted to find out was whether or not we were well within the range of typical vehicle exhaust applications, and we are. That rounds up our presentation today, and I'd like to thank you for attending. This is our contact information. We have Jim Wishusen as our FRP Division Manager, myself, Senior Product Manager, Sam Stelzner, Engineer, Ryan Phipps, Engineer. They both should have a /sales after them. Mike Murphy's our National Sales Manager, and Daryl Fetters, our Western Regional Manager. I'd like to thank all of you.
Thanks, Terry. That concludes our webinar on specialty FRP duct. Please contact our support team for design assistance, quoting, or any other requests. Remember, our website, fiberglass-duct.com, has a complete catalog and other resources. This webinar and all previous webinars are on the Monoxivent YouTube channel. These presentations are linked off our website. Click the Resources tab and click Webinars. Our webinars are held the last Friday of each month. In September, our topic will center on source capture products. We realize you all have busy schedules, and we generally appreciate your time. Thank you for participating today. One other final note, our rep training is coming up next month in just a few weeks, September 10th through 12th in Rock Island, Illinois. The deadline for that is actually today, so if you do have any interest and you haven't confirmed a spot, Paula Pratt is the contact in our office, and she can be reached at 309-794-1000. Thank you.